seconds. Okay, question number 8, page 46. Question says, with a tailwind, a plane flew 3,000 kilometers from Calgary to Montreal in 5 hours. The return flight against the wind took 6 hours. Find the wind speed and the speed of the plane. So this is like our current question. Remember when we had that guy paddling with the current? It's the same style of question. We have to set it up the same way. So let's show a little diagram. Whenever we get a picture, try to make a mental picture of it. Draw it on your page if you have to see what this looks like. So we have our plane, and it flew from Calgary to Montreal. The distance was 3,000 kilometers. And on the way there, it actually tells you in the question, the plane flew 3,000 with a tailwind. So you know the wind was actually helping it on the way there? It took it 5 hours to get there. On the way back, the plane was flying into the wind, and it took it 6 hours. So we have a little diagram. Sometimes it's a little easier to look at. 3,000 kilometers, way there from Calgary to Montreal was 5 hours, way back was 6 hours. So we know the tailwind was helping it on the way there. So we know that both the questions we're going to set up, just like our current question, are going to be equal to 3,000. We know that the distance they covered was 3,000 kilometers. Okay? On the way there, took him 5 hours. Now that's 5 hours. We're going to multiply by the average speed. So actually, I made a mistake. I forgot to set up my variables. So let's take that away. It's okay. Everyone makes mistakes. It shows we're human. So let x equal, and we're going to say the average speed. Okay? We're going to say that that's the average speed of the plane. So average speed. I'll draw a plane so I don't have to write the word. Boom. Let y equal, and we're going to call y the tailwind. So tailwind helps it on the way there and hinders it on the way back. So we'll call this tail or just wind. Actually, it should be just wind, but that's fine. So we have our two variables. We've set them up. Like we said before, our first equation is going to be equal to 3,000 kilometers because that's how far they flew. We knew that it took them 5 hours on the way there. We know that his average speed plus the tailwind, because the tailwind helped. So that's going to be his total speed. We know x plus y is the total speed on the way there, and we know that total speed times the 5 hours equals 3,000. So we can even make a little aside saying that we know that x plus y is total speed. We'll put s, speed from Calgary to Montreal. And we know that x minus y, when the wind in the plane's face, is the total speed from Montreal to Calgary. So like we said before, y being the wind helped it on the way to Montreal, but slowed it down on the way to Calgary. That's why we subtract and add by those numbers. So our second equation would be very similar. 3,000 kilometers was the distance they traveled. Took them 6 hours. The total speed on the way back is average speed minus the wind. The wind slows it down. So we have our two different equations. I'm going to expand so they look a lot more like our linear equations we're used to looking at. So we distribute 5 times the x and the y, and we're going to distribute the 6 times the x and the y. So the equations we're going to work with, equation number 1 will be 3,000 is equal to 5x plus 5y. And equation number 2 will be 3,000 is equal to 6x minus 6y. So we have our two equations. There's 3 styles for solving them. I'm just going to use the letters this way so it's faster. We know we got G for graphing, S for substitution, and E for elimination. What would you guys like to use? Elimination? Yeah, I think that's a good idea. Let's use the elimination because we already did substitution. So, in order To eliminate one of the variables, we need to make the coefficient, so the number attached to the variable, we need to make them the same. So I'm going to eliminate the x's, let's say. So that means I need to make the coefficient of the x's, that's this number in front of the x's, I need to make those numbers the same. So I need to multiply the top equation, the entire equation by a number, and the bottom equation by a number. Anyone know what we can multiply? Get a common multiple. What can we multiply each equation by? 30 is a common multiple. Okay, so 30 is our common multiple, so I'm going to multiply the top equation by 6, so that the number in front of the x is 30. And we're going to multiply the entire second equation by 5, so that the number in front of the x becomes 30. So our two new equations will look like this. 6 times 1,300 is going to be 3,000, not 1,300. 18,000, 30x plus 30y. Our second equation will read 15,000, that's 5 times 3,000, 30x minus 30y. Now I said I wanted to eliminate the x's, so which operation do I need to use to eliminate these x's? That's right, I need to subtract them. Both the x's are positive, so if I subtract this equation, 18,000 minus 15,000 is 3,000. 30 subtract 30 is nothing, so I don't write anything in. This is the part that gets tricky, okay? 30 subtract negative 30. So that looks like this. 30, positive 30, subtract negative 30. That's right. It can also be looking like this, 30 plus 30, 60. So 3,000 is equal to 60y. Scroll down a little. In order to isolate y, I'm going to divide both sides by 60. In the end, I'll have y equals 50, I believe. Anyone want to verify that? Yeah, 3,000 divided by 60.
500. No, wait.
Is it 50? We got it? I want to record it wrong, right? 50. Okay, so y. Y is 50. But what does that mean in terms of the word problem? Scroll up again. Look at our let y. Let y equal tailwind. So we know that the wind is traveling at 50 kilometers an hour, whether it's in our face or it's helping us. Okay? So let's use elimination again. This time we're going to eliminate the y's, and we're going to solve for x. We're going to try to find the average speed of the plane. So scroll down again. Remember our original equations were 3,000 equals 5x plus 5y. Is that right? Yeah. And 3,000 equals 6x minus 6y. Okay? So we had our two set up. I need to eliminate the y's. Luckily, I'm going to multiply by the exact same thing we did above. We'll still get a coefficient in front of the y of 30. So once again, we multiply both equations by the same numbers. This one we're going to multiply by 6. This one by 5. Our new equations, which we already know from above, will be 18,000 equals 30x plus 30y. 15,000 equals 30x minus 30y. So we have the exact same equations. Only difference this time is I need to use a different operation. Anyone know which operation we should use? Jeffrey. Addition. Yeah.
Good job, Jeffrey.
Okay. If we add these together, positive 30 plus negative 30 is 0. It's going to get rid of them. So last time we used subtraction, this time we're using addition. So we'll add them together. These numbers are going to be very different. We're going to have 0, 0, 0, 3, 3. So 33,000. We add these together, we get 60x. And when we add positive 30, we'll put it as an aside just to make sure you understand. 30 plus negative 30, which also could be written as 30 minus 30. is 0, and that's why our y disappears. So, we have our 33,000 is equal to 60x. We need to isolate x, so we divide both sides by 60. What's it going to be? 550? So, according to this, is that right? Did you do that, Kevin? Oh, you just made that up. Oh. Is that right? Oh, okay. 550. Okay. So we look up again at our let x. Let x is the average speed of the plane. So we discovered, we'll go down, so we have our x and our y. 50 was y, 550 was x. So we know the wind was at 50 kilometers an hour, and we know that the plane's average speed was 550 kilometers an hour. So on the way there, we can figure out its total speed. The wind was helping it. So if we were trying to find the speed on the way there, so we'll say that was the x plus y. Speed on the way there is 600 kilometers an hour. Speed on the way back, which would have been average speed minus the wind, would be 550 minus 50 is 500 kilometers an hour. Okay? So on the way back, the plane was traveling 500 kilometers an hour. On the way there, the plane was traveling 600 kilometers an hour. We know the speed of the wind is 50, and we know the average speed of the plane was 550 kilometers an hour. Oh, let's actually, before I do that, entire page. The question. All right, so question 3 on page 48. It says a girls' soccer team held a fundraising car wash. They charged $5 for each car and $8 for each van. They washed a total of 44 cars and vans. Cars and vans, and collected $262. How many of each type of vehicle did they wash? So, once again, we're setting up two equations. This was kind of like our first style. The other question we had done with REM's investment. We know that they wash a total of 44 cars. Oh, let's do our let. Let x equal amount of cars. If you guys use different letters for your variables, that's fine. That's not a problem. I like using x and y. That way we can graph if needed. Let y equal amount of vans. So we know that they washed a total of 44 cars. So our very first equation, 44 is going to be equal to the total amount of cars they washed, so x, plus the total amount of vans they washed, plus y. So our first linear equation, 44 is equal to x plus y. Second equation, it says that they made a total of $262. So we know that $262 is equal to, now we have to figure out how much they charged. And it tells us in the question they charged $5 for the cars. So $5 for every car that went through the wash. So we multiply 5 times that variable. And we know they charged $8 for every van. So 8 times the amount of vans they washed. We now have two linear equations. They washed a total of 44 vehicles. That means cars plus vans. We know they made $262. They charged $5 per car and $8 per van. You guys are going to use either graphing, you're going to use either substitution, or you can use elimination to solve for what they have there. That's the equation set up. You guys are going to use one of the three to solve it.